Alrighty, welcome back boys and girls. It's your main mathematician coming to you live from Summit Academy. In this video, we're working on Unit 7, Lesson 15 now, last lesson of this unit, and we'll do a wrap up in the next video. So what we're going to be working with today is we'll be able to add and subtract numbers in scientific notation. So on that first part, it says decide how many non-zero digits each number will have. So using some of those exponent properties that we had from before, we can multiply some of these out. And what we can also do is we can use that Desmos calculator. So what we're looking for is we're looking for how many non-zero digits it's going to have. So if I look at the first one, I'm going to say I have 3 times 10. Let me actually use parentheses for this real quick. And parentheses on my next one. If I look at this one, again, notice how they multiplied the first value together. So they did 3 times 2, and then they added the exponent since the same base is 10. But what we're looking for is we're going to say, okay, well, for the first one, we have just one non-zero digit. And then for the next one, I can have, if I have 3 times 10 to the 9th power divided by 2 times 10 to the 7th power, again, I have 150, but what I'm looking for is that it's going to be 2 digits. Let me write those two down real quick. So I'm going to say for this first one's going to be 1 digit, and the second one is going to be 2 digits. So let's find out what happens on our third one. So I'm going to type it in exactly as it looks. So I have 3 times 10 to the exponent of 9, and I have plus 2 times 10 to the exponent of 7. And so for this one, I am going to say I also have 2 for that one. So let me write that in. So I have 2 non-zero digits. And for the last one, let's see what we have. We have 3 times 10 to the exponent of 9. I have minus 2 times 10 to the exponent of 7. Now look at that one. That one's going to have 3 non-zero digits. So I'm going to say for that one, it's going to be 3. So just make sure you're careful when you're switching back and forth between those different forms and those different rules. So now on the next part, so let me clear this out real quick. Go back to this one. Okay. So the next part says measuring the planets. It says Diego, Kieran, and Claire were wondering if Neptune and Saturn were side by side, would they be wider than Jupiter? So it says for the first part, it says they try to add the diameters of 4.7 times 10 to the 4th kilometers and 1.2 times 10 to the 5th kilometers. And it says here are the ways they approach the problem. Do you agree or with any of them, and explain your reasoning? So for the first part, it says Diego says when we add the distance, we get 4.7 plus 1.2 equals 5.9, and then the exponent will be 9. So the two of the planets are 5.9 times 10 to the 9th power side by side. And for this, we're going to say Diego is incorrect because it should be 4.7 plus 12 because the exponents will match. Because you have to have that exponent match up when you're adding those together. And it says for Kieran wrote 4.7 times 10 to the 4th power as 47,000 and 1.2 times 10 to the 5th power as 120,000. Added those two together and got 167,000. And we could say this, we can say, let's try dragging that over. It says Kieran is correct, but it is, let's say, hard to compare since it is not in scientific notation. And so what I did there was I changed that 167,000. I'm going to just move it to scientific notation. Again, make sure you're moving those decimal places over. So we'd say it would be 1.67 times 10 to the 5th power. And similar idea, it says Claire says, I think you can't add unless they are the same power of 10. And so it says she adds 4.7 times 10 to the 4th power kilometers and 12 times 10 to the 4th power to get 16.7 times 4 to the times 10 to the fourth power. So we're going to say for this one as well, Claire is correct, but needs to write in proper scientific notation. So we just wrote it as 1.67 times 10 to the fifth power. Again, that number attached to that times 10 has to be less than 10 and greater than 1. And for the last part, it says Jupiter has a diameter of 1.43 times 10 to the fifth power. Which is wider, Neptune and Saturn put side by side, or Jupiter? And we're going to say that Jupiter plus Saturn is going to be greater than, Neptune plus Saturn is greater than Jupiter, since 1.67 times 10 to the fifth power is greater than 1.43 times 10 to the fifth power. And we can just look at those numbers attached to the times 10, because since both of them are times 10 to the fifth power, we can compare them a lot easier. All right, now on the second part towards the bottom, it says when you add the distances, Venus, Earth, Mercury, and Mars from the Sun, would you reach as far as Jupiter? So we have to, actually, before we do anything, we have to make sure we change the values so the exponents match before adding or subtracting. So what that means is this: if I look at this value here, I can say this is going to be the same as, so let me say this is equal to, I'm going to say this is 0.579 times 10 to the exponent 8, because I have to move that over one time so that way it matches up the rest of my values here. Again, I don't have to change that first one because that first one is still just 0. And so now, let's say when we add these together, again, if I look at these distances, since they're all the same exponent time of 10, I can add those first numbers. So what I'm going to say, I can add these numbers together. So let me underline what I'm adding. So I'm adding the value just found, the 1.08, the 1.47, and the 2.28. Because I'm trying to see, is that less than Jupiter's, which is that last value, and we're going to say yes, it is. It is indeed less than Jupiter's 7.79 times 10 to the 8th power. All right, and then for the number 2, it says add all the diameters of all the planets except for the Sun. Which is wider, all those objects side by side, or the Sun? So what we can do is we can actually, let me do the diameters first. So I have to change some of these numbers. So for this first one, I'm going to be changing them. So let's say change to have times 10 to the fourth power. So what I have to do for each of these is, so for the Sun, I have to move it 2 times because I need to change the exponent to 4. So it's going to be 139.2 to the exponent, or times 10 to the exponent 4. This one I have to move to the left one to be exponent 4. These two are already in that form. Same idea with Mars. I have to move it one step to the left to have exponent of 4. And for the Jupiter, I have to actually move it one step to the right to be exponent of 4. So now that I have my numbers changed, I'm going to show you what I got. So I have, for this one, again, notice how I'm comparing them. I have the 0.04, or the 0.4878 comes from Mercury, Venus is 1.21, Earth is 1.28, Mars is 0.6785, and Jupiter is 14.28. Each of them are times 10 to the fourth power, and so we can add these values together, still times 10 to the fourth power, and we're going to say that's less than the Sun's diameter. That's going to be 139.2 times 10 to the fourth power. So we're still going to say it's less than, even though we added up all those planets together. Now moving to the back, we're talking about Old MacDonald's massive farm. It says use the table to answer the questions about the different life forms on that planet. And so what we can do for this one is, it says what is the total mass of 1 cow, 2 sheep, 3 chickens, and 1 farmer. So what we can do is add these together. So what I'm going to write is this: I have 6.2 times 10 to the first power plus 4 times 10 to the second power plus 2 times 6 times 10 to the, so make that multiplication, 10 to the first power because we have 2 sheep, and we have to do 3 times 2 times 10 to the first power because we have 3 chickens. And then last we have to add in that farmer, so we have, or sorry, that, let me back up there. Should be to the 0 power, and then the 1 farmer is, where's the farmer at? Is going to be at 6.2, so I already have that in there. So 6.2 is for the farmer. The cow was 4 times 10 to the second power. We have the 2 sheep and the 3 chickens. So adding all those together, let's see what we get. So what I'm going to do is I'm going to type this into Desmos. Let me share my screen with you. There we go. Let me move that down a little bit. So I'm going to be typing this in exactly as it looks. So I have 6.2 times 10 to the first power plus 4 times 10 to the exponent 2 plus 2 times 6 times 10 to the exponent of 1, and we have 3 times 2 times 10 to the exponent of 0. So all together we're going to add those weights, or masses I should say, and we're going to get 588. So that one we can just put 588, which I will write right here. So all those added together, 588 kilograms. All right. Then for number 2, it says make a conjecture about how many ants might be on the farm. If you added all these ants into the previous question, how would it affect your answer for the total mass of the animals? So what we're going to say is this. Let me change colors here. Let's say total mass, similar to what we did in the previous video. We talked about what happens when we multiply these two numbers together. So I'm multiplying these two numbers together. So I have 5 times 10 to the exponent of 16 times 3 times 10 to the exponent of negative 6, which altogether is going to be 15 times 10 to the exponent of 10, which is the same as moving it one step to the left, so that way this number is less than 10. Increase that exponent by 1, so we're going to have 1.5 times 10 to the 11th power, and we're going to say additional kilograms, because if we add those to the previous mass, we would increase it by a lot. Then for the next one, it says what is the total mass of a human, a blue whale, and 6 ants all together. And so let's add these numbers that we have. So I'm going to say I have my human, which is 6.2 times 10 to the exponent 1, plus 1.9 times 10 to the 5th power for our blue whale. And we have plus our 6 ants, so we have 6 times 3 times 10 to the negative 6 power. So let me type that into Desmos and let's see what we get. So that's equals, let me share screen again, and let's move it to, say, like here, and let me type this in. So that first one we can keep because we have that the human weight in kilograms. Then we have plus 1.9 times 10 to the exponent of 5. Then we have plus the 6 times 3 times 10 to the exponent of negative 6 for all those ants. So yeah, this weird looking decimal, but that's what we're going to say is going to be our weight. So just make sure that you're multiplying those carefully and adding them together. So I'm going to write what we have. So we're going to say there's going to be, I believe that's 190,000, or yeah, 190,062. I have point. We have 4 zeros, 18. Okay. So, and also to make sure you can notice those different parts, I have that 190,000 from the weight of the blue whale. I have the 62 kilograms from the human, and I have the very small decimal from the 6 ants. And it says in the last one, it says which is greater, the number of bacteria or the number of all the animals in the table put together. What we can say is, looking at all the exponents, the closest one is going to be 20. So if I look at the exponent of bacteria, notice how that exponent is 30. So it's going to be a very large number. It says bacteria still has more than all the other creature numbers combined. All right, now for this one, it says evaluate each expression, giving the answer in scientific notation. What we're going to say for this one is, I just want to label that we have the same exponent for each of these. So I'm going to say this has the same exponent, and because base 10 power 4. And so all I have to do for this one is just add those two numbers together. So I'm going to say that's going to be 10 times 10 to the exponent of 4, which is the same as 1 times 10 to the exponent of 5. Same idea for the second one. I can say this one's going to be same exponent. Since both of them are 6, I can subtract these two numbers together. So I'm going to have 3.7 minus 3.3, which is going to be 0.4 times 10 to the exponent of 6. But I have to make sure that this number is greater than 1. So I'm going to move that one time to the right. So I'm going to say that this is going to be 4 times 10 to the exponent of 5. Similar idea for part C. We're now adding these two together, same exponent. Let me label that. So I have same exponent. And we're going to say, okay, when we add these two together, I have 11.1 times 10 to the exponent of negative 3, which I have to move that one step to the left now because my value is larger than 10. So now I'm going to say that it's going to be 1.11 times 10 to the negative 2 power. Again, make sure you're careful with those negative exponents. They can be a little tricky. And so now for this one, I'm going to say pause for your turn. I want you to try it out on your own and check with me. And this is helpful because these already have the same exponent, so you just need to subtract it. So similar to that part C. All right, moving on to number 2, it says solve each equation and check your solution by graphing on Desmos. So make sure you're remembering how to set these up, and I'll guide you through them. So for this first one, we're going to say I need to do our distributed property first. So I'm going to say I can draw these little boxes. So I have negative 2 on the outside. Now on the inside of my parentheses, I have this. I have positive 3x, and I have a negative 4. So I can multiply. I have negative 2 times 3x is negative 6x. And I have negative 2 times negative 4 is positive 8. Similar idea on the right side, I have a positive 4 on the outside, and on the inside of my parentheses, I have a positive 1x and a positive 3. Just make sure that you're not forgetting about that 6, which we'll bring down here in a second. So I'm going to say I have positive 4 times 1x is going to be positive 4x, and positive 4 times positive 3 is positive 12. And so now what I can write inside the boxes is underneath. So I'm going to say I have negative 6x plus 8 equals 4x plus 12 plus 6. All right, since I have variables on both sides, I need to get rid of one of them. Find your lower coefficient. So I'm going to say that negative 6 is going to be our lower one. So I add the opposite. So I add 6x to both sides. I need to get the variables to one side. And I can also I can do this step where I add these two together. So I'm going to say that on my left side, I just have 8. And on my right side, I have 4 plus 6x is 10x. And then I have 12 plus 6 is 18. make sure you can subtract 18 because I need to get that those constants to the other side of the variables. So now I subtract both sides by 18, and I say I have, it's going to be negative 10 equals 10x. And then my last step is to divide both sides by 10. Always divide by that coefficient. And so I can say x equals negative 1. And so to check, make sure you can multiply, or sorry, not multiply, let's say type these into Desmos. So what I'm going to do, I'm going to say in Desmos, I'm going to type out my left side in one equation, and then I'm going to type out my right side in one equation and see where they intersect. So let's do exactly that. So I'm going to share screen again, and let me actually put it on here so that way we can see it. We'll just have to remember that we said our answer was negative 1. Okay, so let's clear this out. So I'm going to say, okay, y equals, for my first equation, I have y equals, and I said negative 2 parentheses 3x minus 4. So there's one line, and my second line, or my right side, is going to be 4. I can always type y equals, so I have 4 times the quantity x plus 3, and then I have plus 6. Let me change this to green. Let's do that one. Okay, and so now I have to find where they intersect, so I scroll on my wonderful calculator, find that x value, and so I'm going to say that x value is negative 1, which is good, so I know that this is going to be right. So just make sure that you can use that carefully. Alright, so now for these two, I want you to, I'll walk you through this one. This one we can do, so I can multiply each of the terms inside the parentheses by 1/2. So I'm going to say this is going to be 0.5x plus 2, and I have minus 6 equals, and then the right side stays the same because we didn't do anything to it. Then I'm going to add 2x to both sides to get the variables on one side. And also too, I can combine these two, that way I can save a step. So now I have this is going to be 2.5x minus 4 equals 8. Add 4 to both sides, and we'll have this. We're going to say we have 2.5x equals 12. Divide both sides by that value. So I have divided both sides by 2.5 since that's the coefficient. And I'm going to say that x equals, let's say 4.8. So let's check it out and see if it works. Again, same steps as before. We're going to graph our left side and our right side of our equation. So let me hit that home button. I'm going to clear these two out. So now I have my left side is y equals 1/2 parentheses x plus 4, and then I have minus 6. So there's one line, and my second line is going to be y equals negative 2x plus 8. So find where they intersect. Again, I'm looking for the x value. Notice how that x value is 4.8, so we know it's good. So just make sure you're checking using Desmos. Right. And for this last one, I want to make sure that you guys can do on your own. So make sure you can pause for your turn and check with me. Use Desmos to graph. All right, and then lastly, for that X ticket, it says Elena wants to add 2.3 times 10 to the 5th power plus 3.6 times 10 to the 6th power. And then she writes them, adds them together, and then just adds these two together to get the 5.9. And it says, explain what her mistake was and what the correct solution is. So we can say this. We can say first that Eleni needs to change the exponent of the first number so they have matching exponents. And so what we can do is this. So I'm going to rewrite it so that way let's do orange. So we're going to say, again, that first value I need to change. So I'm going to say instead of 2.3, I need to have an exponent of 6. So I have 0.23 times 10 to the exponent of 6 now. I'm going to say that's going to be plus, still same second number, so that one's okay, times 10 to the 6th power. Now we can add these two together to get our value. So I'm going to say this is going to be equal to 3.83 times 10 to the power 6. So just make sure that those exponents are going to be the same before you add or subtract them. Be sure to ask questions as they arise, and as always, super slam that subscribe button.